Hey everyone, and welcome. When you think about Amazon S3, you probably think infinite scaling, right? And sure, that's true, but it's only half the picture. What if I told you that you could actively tune its performance to slash your wait times and your cloud bill? Well, in this explainer, we're going to show you exactly how to do that.
All right, so here's the game plan. We're going to kick things off with the S3 Speed Challenge itself. Then we'll dive into how to upload massive files way faster. After that, we'll tackle the problem of global latency for your users all around the world. Then we'll get into some really intelligent ways to read your data. And finally, we'll wrap it all up with your key takeaways, a toolkit you can start using today.
So let's get right to it. Is your S3 performance secretly costing you? Because every single second your app is waiting on a file, that's a hidden cost. It hits your user experience, it slows down your application, and yeah, it definitely pads your cloud bill. This inefficient data transfer thing, it's a silent killer for performance, but it's one we're absolutely going to fix.
Now, here's the secret you gotta understand. Unlocking peak S3 performance isn't about flipping some magic switch in your infrastructure settings. S3 already handles all the request scaling for you automatically. The real, game-changing wins come from how your application is designed to talk to it.
And this slide right here just nails it. This is the core philosophy. The game isn't about trying to provision more power, it's all about designing for efficiency. It's about cutting out the unnecessary data movement, basically working smarter, not just trying to push data harder.
So let's look at the first major tool in our kit. I want you to imagine you have to ship a giant 20-volume encyclopedia set. Now, would you try to stuff it all into one massive, clumsy, fragile crate? Or would you ship each volume separately? Of course, you'd ship them separately. It's faster, it's safer, and that is the exact idea behind multi-part upload.
So here's the magic behind it. Multi-part upload takes that one giant file of yours, carves it up into smaller, more manageable chunks, and then, here's the key, it fires them all up to S3 at the same time, in parallel. This is an absolute game changer for both speed and reliability.
So, when should you use this? What's the magic number? Well, the rule of thumb is super simple. If your file is bigger than 100 megabytes, you should be using multi-part upload. Any smaller, and the overhead isn't always worth it. But when you're talking about huge files like multi-gigabyte video archives, ML models, or big datasets, it's not just nice to have, it's absolutely essential.
And the process itself is just beautifully simple. Your application handles splitting the file into chunks. Then, those chunks get uploaded all at once in parallel. That's where all the speed comes from. And here's the best part. If one of those chunks fails because of a network hiccup, you only have to resend that one tiny piece, not the whole darn thing. Once all the parts get there safely, S3 just stitches them back together into the original object. Easy.
Okay, so large files are handled, but what about the tyranny of distance? You know, what happens when your user is uploading from Sydney, but your S3 bucket is sitting in Virginia? That physical distance creates latency, and that's our next big challenge.
Think of a direct upload, like taking all the local back roads to get across the country. It's going to be unpredictable, you're going to hit traffic, you're going to hit potholes, you're going to get delayed. Transfer acceleration, though, that's your private global superhighway. Your data just takes a short hop to the nearest AWS Edge location, and then it zips across Amazon's own private optimized network, completely bypassing all that public internet congestion.
So, where does this really shine? Well, if you've got users all over the world trying to upload to one single central S3 bucket, this is a no-brainer. It's also perfect for remote offices that need to send daily backups, or for research teams out in the field trying to upload massive data sets from halfway across the planet.
Okay, we've talked a ton about getting data into S3, but getting it out efficiently is just as critical. I mean, think about it. Downloading a massive file just to find one tiny piece of information is a huge waste of time, bandwidth, and money.
And this is where S3 Select is it's genius. It's like asking a librarian for a specific sentence from a 1,000-page book. Instead of having them lug that entire heavy book over to your desk, they just find the sentence you need and hand you that one little slip of paper. You get exactly what you need, and you get it instantly.
Let's make this real. Imagine you've got this massive, 500 megabyte log file. It's full of thousands of JSON events, kind of like what you see here. Now your application only needs to know one thing, the status of a single login event. The old way, you'd have to download that entire 500 megabyte file just to find that one little value.
But with S3 Select, you just run a simple SQL query right on the file in S3 and boom, this is what you get back.
just the data you asked for. The difference in data transfer here is staggering. We are talking bytes versus megabytes. It's faster, it's cheaper, and it's just unbelievably efficient.
So S3 Select is our scalpel, right? It's perfect for surgically extracting a piece of data from a single file. But what happens when your question is bigger? What if you need to find trends across an entire data set that spans thousands, maybe even millions of files?
And that is the perfect time to bring in its big brother, Amazon Athena. This table lays out the difference perfectly. Think of S3 Select as the scalpel for a single file. Athena, on the other hand, is your powerful serverless query engine for an entire data set. You use S3 Select when your app needs one piece of data from a file it already knows about. You use Athena when you need to run complex, interactive analytics and ask those big questions across your entire data lake, right where it lives in S3.
So after digging into all these different tools, it really all comes back to one powerful guiding principle. This isn't about brute force. It's about intelligent design. It really is about working smarter, not harder.
So here it is, your actionable toolkit, your S3 performance cheat sheet. Got a big file? Multi-part upload. Users are far away? Transfer acceleration. Need just a tiny snippet from one object? S3 Select. Need to analyze the whole data set? That's Amazon Athena. It's that simple.
And this right here is the bottom line. This is what I really want you to take away. Every single technique we've talked about today all serves this one goal. When you reduce unnecessary data movement, you are directly building faster, more responsive applications, and at the same time, you are lowering your AWS bill. It's a total win-win. So, as we wrap things up, I'm going to leave you with this question. I want you to take a look at your own applications, your own workflows that use S3. Think about where those delays are, where that waste might be happening. Now that you have the toolkit, which data bottlenecks are you going to go solve first?